So, good morning, everybody. It seems that it's time to start our today's webinar. And I'm glad that we can kick off with it today because I think talking about batteries and smart battery solutions, you can never talk too much about them. And our today's webinar is therefore called also Smart Batteries, Aggregate, Manage and Trade. My name is Jan Tiemann, and I'm the Marketing and PR Manager here at Fusebox. And I would actually like to start off by saying that today's webinar marks a milestone for both Pixii and Fusebox Energy, as we have set out in 2021 to produce a smart battery system that is capable of both connecting to the energy grid and energy markets, and which can benefit the battery owner by being available and then being capable actually of using all the new balancing services that are available on the market now and also tomorrow. And so now, 2 years later, we are successfully actually concluding our objectives. And today's kind of webinar is the place where we can present our results and showing how smart batteries can do everything on today's energy markets. And this is why I had the pleasure to introduce today's presenters. From Pixii side, we have Dr. Ole Jakob Sördalen. And Pixii itself is a Norwegian company who is designing and then manufacturing and selling energy storage solutions. From Fusebox side, we have Alexander Sepp, who is the head of our strategic partnership. Now, Alexander has a lot of experience from consulting and talking to different asset managers, battery owners across Europe. So he knows the playing field. He knows what the kind of things are, what people are looking for on the market. And also from Fusebox, we have Donatas, who is has basically the most experience from our side at the moment for managing Fusebox's battery portfolio. And also a quick note about the technical aspects of today's webinar. As you have already noticed that we are recording it. The recording will be made available to you after the presentation. We're planning to planning the webinar for 1 hour, and during that hour, this I think is a very good kind of place to start a conversation also with us. So it shouldn't be just us talking. If you have any questions, definitely let us know. You can do this by either raising your hand. There's a raise hand button at the top of the screen in Teams, or you can write it in the group chat or under the Q&A chat, which are also you can find at the top. And whenever you have a question, just shoot away. We'll not be waiting till the end of the session to ask them. So ask away, basically. And that's it from my side. And I'll give the microphone over to Alexander from our side.
Yes, well, I can hear myself. Yeah, so yes, hello everyone. Pedro, can you hear me?
Yes.
Yeah, oh, good. So yeah, as Jan has already mentioned, it's a big milestone for us. Just the last webinar in terms of green ICT program, but also sorry. Yeah. have an issue with. Sorry, guys, I have an issue with the microphone. Yeah. So yeah, it's a milestone within the Green ICT program. It was a long 2 years, and we are happy to see that quite big and substantial developments have been done during that phase. Yeah, so let's move on with the topics of today's webinar. Next slide, please. Yeah. So what we were thinking, like what kind of challenges or pain points that the industry is facing now and will be facing even more during next 25 years. And of course, that is growth of the renewables within the overall energy mix. We already see now that the prices due to that are unstable, especially in Estonia. This summer, we have seen that there were quite a lot of prices with a minus, showing that the prediction of the renewables production is to the point is a weak point. Of course, that can be solved with installing batteries to the next to the PV park, wind park production units. Also, we understand that with the renewables, it will be even harder to make a long-term forecast, and of course, batteries would make that prediction smoother or more predictable. Also, limited flexibility with the more renewables. It's quite hard to use their flexibility. It's in some cases it's just turn on and off. And of course, with installing the smart batteries, you can smoothen the process. You can prolong the utilization of the connection point. But also with the growth of flexibility or with the renewables, we will face eventually the cannibalism of the production, meaning that the price will be quite low during high sun radiation or wind, so that the grid-scale batteries can help to push to utilize that energy into the batteries and use it during more pricey hours within the day. And of course, one of the topics that is quite hot among big utilities, small utilities, is distributed energy resources management, forecasting management, and for sure with the batteries, as I have already mentioned, all the prediction would be much smoother, much controllable, and yeah, that eventually will affect the prices and yeah, the more smart way of managing the portfolio of the utilities. Yeah, next slide. Yeah, so there are like two ways of finding the solution of market volatility. There is a more traditional way of using fossil fuel peaker plants, where you ramp up or down the production during certain hours or moments within the day. But we see that more and more companies and PV park, especially wind park owners, are installing smart batteries to their sites, so that the same fluctuation can be managed with the help of the batteries instead of using fossil fuel picker plants. That, of course, gives us additional points in terms of being more green and yeah, those green points. Next slide. Yeah, as you can see, the energy storages with a smart Fusebox software can cover almost all needs within the grid or all pain points within the grid. The main and probably the foremost is helping grid to be more stable. Batteries nowadays are used in all range of frequency fluctuations. Also, for a better utilization of renewable production. Especially, I know that I would say even that we have seen that the previous year was a big boom of installing extra batteries to the renewable plants, but we see it even more the next year and the year after. Also, batteries is a really good way to enter to the ancillary markets. Those assets are the easiest to pre-qualify if it's needed, but also ancillary markets in some countries are providing quite good income, so the batteries became an asset to invest in. I know that in, for example, I know the Scandinavian markets and the return of investments there are around 2 to 3 years for the battery, so it's quite good. Also, we have seen that companies who are facing grid congestion or problems with their energy distribution are using batteries to avoid peak prices or to get extra points, as I mentioned previously, and in a green energy consumption. Also, I know that those companies are also installing PV panels, for example, on their roof, and they would like also to utilize that energy the best way possible. And of course, EV charging in some since the EV electrical vehicles become more and more popular, EV stations are installed in rural areas, and so the grid is facing the grid congestion problems. And I know that the batteries in that cases were used as an additional tool to overcome connection point restrictions. That can be restrictions in terms of, as I mentioned, grid congestion, but also tariff system, etc. Next slide, please. So just to sum up, what benefits you can get by using smart batteries with a Fusebox platform. Of course, the battery is the main tool to maximize your connection point efficiency, meaning that if a PV park, now for example, in Nordics, PV park is working only 4 or 5 months per year, So basically, you can still utilize the connection point capacity during the rest of the year with the help of the battery. Also, to access new markets, as I mentioned, ancillary markets in some countries, fast frequency markets with a high potential for income. Yeah, I know in some countries people are just investing in batteries to get additional sources of revenue. As I mentioned, also there is with the battery you can overcome a connection point or network restrictions. Especially that is crucial with the growth of your site. I know that there are certain problems, for example, for the factory, if they would like to install extra, for example, EV chargers for their new cars, and they have limitations from the grid, so they are using batteries for that. And also with our platform, you will get near real-time measurement data, not only about from your battery, but also from other assets that will be connected. So it's also a nice tool to monitor and manage your site consumption versus production. Yes, and that everything can be seen on your user-friendly portal. You can see a picture, for example, from one of the site on the left. And of course, everything will be automated. So if you need a power distribution, it will be automated. If you would like to have your batteries bidding on ancillary markets, it can be automated. Grid congestion automated. Yeah, and of course, reporting every month you will get report on your battery activity. So it's we see that Fusebox is like a really nice tool, especially with the Pixies, because with Pixies we have done platform-to-platform integration. Yeah, so eventually, if the Pixii battery will be connected to the internet, local installer should send us a host ID, and let's say in 15 minutes it will be available at our portal. So yeah, I will give a word to Ole Jakob. So he will tell you a bit more about Pixies. By the way, Ole, I would like to congratulate Pixies of receiving the Norway's fastest growing tech company. It's you have done a lot of work for that. Congrats.
Thanks for that, Alexander, and for the good introduction and overview of the project and use and integration of energy storage. My name is again Ole Jakob Sørdalen, or just OJ for short. I am the Chief Innovation and Sustainability Officer of Pixii and one of the co-founders. And I've also been the project leader of Pixii in this very good project together with Fusebox. So I will say a little bit more about the enabling technologies for making batteries useful in various applications integrated by Fusebox. So yes, as Alexander alluded to, we just received an award from Deloitte, being awarded the prize for the fastest growing technology company in Norway. So that's based on the growth during the last 4 years, and 2 of those we have then been in the project with Fusebox here. So that's partly thanks to that project, I would say. Yeah, you can click the next slide. So what does Pixii make? Well, Pixii, we don't make the batteries. The batteries are third party, but what Pixii makes is the essential technology to enable smart use of these batteries into the grid, into where there is a flexibility need. So we make literally the component that connects the flexibility source, the battery, to the flexibility need. And we do that by designing and manufacturing what we call a Pixii box, a 3.3 bidirectional power converter from DC to AC and vice versa. And we have a little bit unique concept there, partly based on our telecom background, where we have a very modular and scalable concept, where we have actually only one component or power converter. And we can scale up the capacity as required by putting a number of these boxes into a cabinet, like as shown here. So in this case, we have a fridge size energy storage system, pre-wired, everything included there with batteries, third party, and power converters, in this case 15 of those, making then up a 50 kilowatt power conversion for charging and discharging. And in this case, depending on the chemistry of the battery, 50 kilowatt hour. The second important component that we are developing is the system controller, or what we call the Pixii gateway. So it's a component that communicates with all the batteries and also each of these Pixii boxes and other internal things like the smoke detector, door opening detectors, fans, etc., to enable that the system operates well. But it's also literally the gateway to the external world and to then the Fusebox platform. So that's our technology, our concept. And again, it's modular and scalable internal in the system, as well as you can scale it up by adding a number of these systems to scale up the total installation capacity. And we have also made one power base where we can put 12 of those to get the capacity further up. So what are the main functions and benefits here?
Ole,
Yep.
I can't really pass this opportunity to actually ask you a question. You have the best, I think, knowledge about what the clients want at the moment. So what is your feeling? What kind of size usually goes on the market, and what's the kind of the sweet spot?
Yeah, so again, the size of the energy storage market as such is very wide. So that's from residential, from say a 3 kilowatt and up to, and then utility scale at big solar or wind farms, etc. And that would be tens of megawatts. So the market is very broad. We can scale them into residential, commercial and industrial, and utility scale. So we started in a commercial and industrial scale from some tens of kilowatts and up to a couple of megawatts. So that's the market we are into so far. And the sweet spot, I would say a few hundreds, couple of hundreds kilowatts. That's what you could fit with smaller distributed renewable energy generation sites, and also to electric vehicle charging points. So that's some of the sweet spots and the typical market size in terms of capacity that we are into. And also by aggregating through platforms like yours, it's also a nice size for aggregating up frequency regulation services as well.
And as I understand, then you can always like expand if need be.
Yes, you can expand both at one site by either adding more Pixii boxes into each cabinet or batteries if you need more storage capacity, or you could just add on additional cabinets also up to the size of the transformer.
Okay, sounds good. Thanks.
Yeah. So yeah, when it comes to the main benefits for an energy storage system, it's threefold. You could use this to save costs, or you could boost your power, or actually also generate revenue by selling flexibility. To save costs, there are various functions, configurable functions in the energy storage system. One is the time of use. So as you know, the electricity prices vary, at least in the Nordics, from hour to hour. And then, of course, you can use the storage to adjust your consumption profile to increase the consumption when the price is low. Also, if you have excess solar power generation, you could use the storage to store that excess power into the batteries and use it yourself later instead of purchasing more expensively from the grid, and also pay taxes and grid tariffs. In some markets, you also have to pay a fee for reactive power consumption, and the Pixii boxes can be configured to adjust the reactive power. So that could also actually save you costs. And then lastly, peak shaving, that could reduce the so-called demand charges, where in some markets the customer has to pay for the highest power peak per month. So that's some functions to save cost. To boost power, again, it's the same function, peak shaving really, but you use it for another benefit. If you have a limited transformer capacity, for example, for EV charging, you can just add energy storage system behind the transformer and increase then the apparent power capacity behind the transformer and the fuses. And also by having phase balancing, because the system could balance the loading per phase, you could also increase the total consumption or the capacity, so you are not limited by the most loaded phase. And then lastly, which is maybe the most important and relevant one in this project, the cell flexibility, and there are various markets from the transmission system operators for frequency regulations, like fast frequency reserves and frequency containment reserves, disturbance especially. But there could also be local markets paid for by the grid companies for local grid decongestion. A little bit early still, but it's an coming market as well. So the local flexibility market. And then also you could also participate in energy market with energy arbitration. So these are the functions and the benefits that are most relevant for energy storage. So you could go to the next, please. Yeah, also now comes some animations to illustrate how you could value stack these functions. So firstly, you think of that you have an existing site. It could be a petrol station or it could be a restaurant, and typically they have limited grid power capacity because they traditionally didn't need more, but now increasingly they need to add EV charging to attract customers. And as you see here, then you have then you will have too little grid capacity to serve that. So then you could add energy storage again to boost power capacity, to have more capacity the hours that you need it. And then once you have energy storage, of course, it's very easy, convenient to add also solar energy, and you could then store excess solar energy and use it for example, EV charging or yourself later. And with the Pixii modular concept, if the capacity need increases, you could just add on more capacity later. And then lastly, it's quite easy to predict when you need the capacity locally for power boosting, but that means that there are many hours you don't need it for power boosting or other local services. Then you have also flexibility that others would like to have access to, like the transmission system operators, and then you could sell that flexibility into the market and generate revenue. So this is an example where one tool is a multi-tool and can provide various benefits and services. And then just you can go to the next. In this project, we have been fortunate to be able to install physical systems at 4 different locations in Estonia and Finland. This is one example from a hydropower plant in Finland. It's a runoff river, so it doesn't have much flexibility itself for the hydropower plant generation. So they've installed together with Fusebox 2 cabinets, 100 kilowatt hour, to provide more flexibility there. So that was the first installation. And then the next one is from shopping center in Finland, 5 cabinets, but that was configured for 150 kilowatt, 250 kilowatt hour, for also providing flexibility services and generating revenue. So hopefully now with these examples, you see that Pixii, what we do is actually in a way developing tentacles out in the grid. We can sense the pain points, and we have the capabilities of providing massaging features to push gently at these pain points in the energy system to remove congestions and ensure total system stability in terms of frequency. And it's well integrated then in the system, integrated by Fusebox. So the combination has turned out to be very good for the society and for the investors and stakeholders involved. So again, thanks from my side for the good cooperation with Fusebox and to the sponsors of this very useful project, which again has been instrumental for us for the nice growth that we have experienced the last couple of years. Thank you so far.
Thank you, Ola. And we have a couple of questions actually coming from the chat. So the first question is coming from MZ. And the question is, what do you think about using batteries in demand-side services, demand-side response services? So I guess we're going to go into that shortly anyway. So we're going to look at the real-life business models, how we can use the batteries. And one of them is definitely demand-side response. And the second question comes from Vitsas, who is asking, hi, can you elaborate on the installation and maintenance protocols for the energy storage equipment? So this, I guess, goes to you, Ole.
Yeah, the first one first, demand-side management. Of course, it's very suitable for that. And I would add that, of course, if you have other flexibilities at your facility, like thermal loads or something like that, you should always try to exploit the inherent flexibility that you have in your process or at your facility. That's requiring less investment cost. But energy storage could be an add-on complementing those. And the nice thing is that with energy storage, you don't interrupt the physical processes at the facility. So it introduces less risk. So that's the nice thing. And of course, it's very easy to program and schedule, and it could be always available for providing the flexibility that you need. So that's very suitable. The second question was related to installation protocol. I'm not sure if I understood that correctly.
Yes, the installation and maintenance protocols for the energy storage equipment. And if you can elaborate on this.
Yeah, installation protocol. Well, I'm not sure exactly what they are thinking of, but so the customer would purchase this, we deliver it, we typically, but everything can be agreed on in each project. So we need some local installers to connect it to the electricity system. But the system is, I would say, very easy to install because everything comes pre-wired, but it needs a connection to the electricity power, and it typically needs an Ethernet cable, and that's all really. And then we assist with the commissioning to configure it, get it up and running, doing some test runs. And that's it really for the installation and commissioning. And in addition, there would be some integration with the Fusebox to get it up and connected to the Fusebox platform if that is desired. But I'm not sure if I'm answering the question there. When it comes to the maintenance, not much maintenance required. Should monitor the state of health, of course, but typically you can expect 10 years lifetime depending on the use and depending on the temperature. But depending on the environment, there are some filters in the door that might be changed now and then. All that could be done by us through some service agreements. But apart from that, not much service required. Or I should say, on the technical side, if you have LFP batteries, it might be that you need to calibrate LFP batteries now and then if they are around 50% state of charge, because LFP batteries have very flat voltage curves. So it might be that the battery management systems lose track of exactly how charged the battery, is it 40% or 60%. But by having some recalibration every couple of weeks, then it gets a new, then it knows that, okay, now the state of charge is 100%, and then it's calibrated again. But again, these are features that are configurable in our system. But just a note on the, it's not a service, but a need for calibration of typically LFP batteries.
Okay, sounds good. Thanks.
Small one. Yes, we are moving further with a different kind of solutions, and what we see now are the most popular, at least in our portfolio, are either grid scale batteries or commercial scale batteries or behind the meter batteries. Basically doing the same thing, but still a bit different. So if you look at the picture on the left, it's a grid scale batteries. Usually these ones are utilizing the connection point capabilities the most efficient way. Usually they are accompanied with big PV parks. So that PV parks can utilize energy during, for example, negative hours, and use it or sell it to the grid during higher hours. And commercial scale or behind the meter batteries are the ones that participate in power distribution services. Also, they are used for grid congestion issues. Also, if there are kind of, for example, tariff limitations, so the client use them for self-consumption. As we have previously mentioned, also covering let's say the EV charging station consumption, or covering certain hours where client faces the peak in the consumption, for example. From our end, everything, as I mentioned before, can be automatized and really be smooth and easy. Next slide. Yes, and further on, Donatas will describe several business models or case studies in a way that we have right now in our portfolio. Of course, there are more of them than only 3, but the most characteristic in our portfolio. So the first one is participation on ancillary markets, all kind of ancillary markets, starting from MFRR, AFRR, but also FCR or FFR. FFR, for example, the reaction time is 0.7 seconds. So batteries are one of those who are able to provide that kind of a connection speed. And also ancillary markets allows to bring the investments of the battery down to a couple of years. It depends on the market, of course. So the business model number 2 is energy arbitrage. As I described previously, it's utilizing the PV park production the best way. Also, just shifting the production, consumption, and overall energy management within the site. And the business model number 3 is minimizing energy costs. This one is describes this energy distribution within the hybrid site, where you have sources of production, but also consumption. Maybe you have also spreaded sources of production, like combined PV park and wind park. So if there is a issue of keeping your consumption from the grid as low as possible, then energy storage solution coupled with PV park is, I wouldn't say the one and only, but the most suitable solution among others. So yeah, and further, Donatas will take his turn. Also, I think that Donatas can answer the question about protocols and how we connect to the battery as well. Just that Vitsas will have the broader understanding of how we do it. Thanks.
Yeah. So thank you, colleagues, for such a great introduction to this presentation. I am, as said, Donatas. I am EMS product owner in Fusebox Energy, and today I will speak about these 3 business models in more details. So let's start with this, let's say, most attractive business model of auxiliary markets, because this most probably will bring you most revenue if you, of course, using the Fusebox software. Then how those business case explanation will look like. I will start with the needs that you must have to use this business case. Then I will talk about what Fusebox offers, and then explaining the results of the business case usage. And of course, I will bring real-time examples from the Fusebox software, explaining how the exact business model looks like, what is the benefits, explaining the signals and so on. So for the auxiliary market, you must have assets that can be regulated, controlled, and you also need connection with the transmitting system operator. And that can be done only with the Fusebox usage. So about this real-time telemetry, what do we mean by that? Basically, we need like a minimum of the few things. It's basically a state of charge of the battery, the temperature of the battery, the status of the battery, and well, if the object has some renewables like the solar farm, then the solar farm production, so that you can make them cooperate with each other. Then, of course, and if you have like a wind generator, then this, and some other asset that can bring energy, this would be a huge plus. So what Fusebox offers in this case? Well, there's actually a huge package of things, starting from the different bidding strategies, giving you possibility to participate in different markets, giving you overview about your assets, making your reporting and billing automatic and very simple and understanding with you and the TSO. And of course, Fusebox as well offers support and training, giving you suggestions about how your assets should be regulated. We're experts in that. So, and the results, well, of course, this opens you another revenue stream. This makes possibility of your assets to reduce your investment time by participating in different markets. And of course, it maximizes your like connection points if you have telemetry capabilities of your connection points and your renewables, taking them under the consideration as well. So, well, this business model is just great. What can I say?
And did I understand correctly that this is also one of the kind of the main things that the connection with the TSO that you can't really get with other kind of optimization solutions or software?
Well, yeah, Fusebox offers this TSO connection, and this is the only way how you can participate in the regulation markets. Otherwise, well, it's just impossible.
Okay, just so that everybody knows, TSO stands for Transmission System Operator, meaning the company, local company who is the owner of the grid. So this is the basis where the ancillary market comes from.
Okay, so let's move on to this graph. This is taken from the Fusebox software. And it's a very nice graph. It is explaining the consumption for this vertical line and the time on the horizontal line. Well, on this example, there is around 5 hours of the asset usage, let's say. So if you pay attention to this blue line, this is the consumption of the asset. And those brownish signals are actually those transmitting system operator signals, TSOs. And during this, we can see that the power consumption is dropping, meaning that the power is released, and releasing the power actually earns you money. And you ask how you earn this money. So basically, this TSO, he's calculating how much power we're given. Well, in this case, we're offering MFRR up, which means giving power to the grid. Well, they calculate how much kilowatt hours you gave. According to this, they pay the asset owner. And you ask, what is the price for this? Well, it is actually pretty simple. There is this auxiliary market pricing, and it's made by bidders. There's like a merit order of all the bidders that participate in it, and the last one dictates the bid price.
And do you know how these prices compare to the, let's say, day-ahead prices?
Yeah, it's a good question, Jan. Well, sometimes they can be like 10 times more different or more attractive, let's say. If we're talking about like spot price, it could be like 100 euro megawatt hour, and on flexibility hour and the flexibility markets, it can be like 1,000 euros the same time, the same hours. It all depends on how much energy there is or needed, let's say.
It sounds lucrative.
Yeah. So the second business model is about the energy arbitrage. Well, for this, what you need? You actually need an actual assets like batteries, and also a possibility to monitor and control them somehow. Huge plus would be if you have like cooperation with the renewables at your site, so that you can store energy to the batteries and use it when you want it, or where it's needed, or where it's most profitable to sell it, for example. And there are also a huge plus if, for example, again, only through Fusebox software, if you are using this TSO like integration, this gives you a possibility to participate in other markets as well, not only the spot market, like a flexibility market. Then it offers you like a possibility of making one-way arbitrage. What I mean by that is that you basically can charge your batteries, for example, from spot market and discharge it on MFRR, which is also giving you a way of earning more money with your assets. So what Fusebox offers, in this case, of course, most smart and best way of charging your batteries or manipulating your assets. It has a way of giving you a simple overview of your asset behavior. It has automatic implemented automatic reporting for you and the TSO if you have this possibility. And of course, it considers your renewables for your assets. And as a result, well, of course, considering that you're using Fusebox, then there is another revenue stream for you, which shortens your investment time. And then, of course, you can participate in different markets, then earning more revenue, becoming more greener, then saving CO2 and maximizing your battery asset performance. So about the example, well, this is another example from the Fusebox portal. A good one again, because this asset has renewables at its site, and I explain about it shortly. So basically, you can see this blue line once again is product is like a consumption of the asset. In this case, this is a battery, and you can see it is charging during the low spot prices, and starting to discharge during the higher spot prices, or gives it to the local consumption. Depends on the specific settings that can be simply adjusted on the Fusebox software. And in this case, this object also has a wind generator. So this is considered. Basically, we can see that the power that the battery is giving is not its maximum, because it is considering the connection point strict limits. So basically, it does also the congestion on this side. Yeah. And one more thing that I wanted to explain is that on those graphs, when you see the green is like up or like a charging, and this brownish color is like discharging or giving energy to the grid. Well, the last but not least business case is basing on minimizing. Well, again, what you need some sort of assets to have on your object, then possibility to control it and monitor it, and a huge plus also would be if you have some sort of renewables like wind generator, solar park, or something else that generates power, so that you can store it to your battery asset and use it when you wish. And well, what Fusebox offers is, of course, the most smart and optimized way of energy usage to store it in your battery asset. It manages the most in the most best way, and makes again the reporting and billing automatic, and gives a simple overview so that everyone can understand. And the result is most obvious. You will save cost of your electricity bill. So the last example from our software, you can see this again already familiar graph. Well, the blue line shows again the asset energy is taken from the grid. It means that the asset battery is charging again during the spot price lower hours, and then is discharging for the several hours. It's actually example of almost all day. It's like 16 hours. And it shows that the battery can be charged during 3 lower spot price hours and discharged during 8 higher hours. And you can also see that the discharge is happening with the lower power. Well, this is because the asset owner wanted to strict the power outcome so that he will use the power from the battery for the longer period of time. Well, yeah. I think that's all from my side. Thank you very much. And
yeah, thanks. We have a couple of questions. So just being conscious of time, I'll shoot away. MZ is asking, could you explain, can we use energy storage system for flexibility services when we have a behind the meter installation? It's a good question. So, Alexander, are you up to the task on this?
Yeah. So the short answer is yes, we can. But of course, we need to measure also before the meter to know the limitations on the system. Yeah, that's the easy answer, because then we will. So eventually, when the demand side response activation will happen, we need to show that the consumption from the grid has dropped down, and calculate how much we were able to, and the consumption from the grid will drop down due to switch to the battery source for consumption.
Mm. And I guess you would need anyway a connection to the TSO in that case, if using flexibility services.
Yeah. In that sense, Fusebox provides that.
Mm-hmm. Okay, understood. And second question, a follow-up comes from MZ as well. Could you explain, we combine all business services in one battery energy storage system installation?
No, it's for sure it's a combination of all those services. The only restriction is that you cannot use all of them at the same time. So it's basically the fine-tuning of the parameters or limitations of the site and finding the right. Now, for example, we will put that during the peak hours. We know the peak hours of consumption. The battery will be used for covering the demand on the site, but on the other hours it will be available for demand side response. It can be also possible.
Awesome. So I think we have run out of time at the moment, but if you have any further questions, then do drop us a line. You have all the contacts on the slide, or you can find us on either Pixii or Fusebox homepages. And thank you for listening, and hope to see you soon. So thanks everybody. Bye.
bye.
Bye-bye.
Ciao.